That you want to understand before you build a battery pack. So the first thing is the capacity. So to build a battery pack with a certain capacity, you need to understand that cells wired in parallel add up the capacity. Voltage, however, stays the same. And in regards to voltage, what you want to know is that cells wired in series add up the voltage. However, the capacity stays the same. Building a battery pack is that they consist of parallel rows of cells, all joined in series. So this would consist of something like this. So let's say this is one parallel row. So all of them face the same way up. Now, let's say these are all 2000 milliamps each. Okay, as we said before, when the cells are joined in parallel, the capacity adds up. So each one of these is 2000. Which means they all add together, which gives you 10,000 milliamp hours. Okay. However, you cannot have this with a very high voltage because each cell is rated at 3.6 volts. So, as we said before, when they are joined in parallel, the capacity adds up but the voltage stays the same. So this is still 3.6 volts. So to combat this, we need to obviously, thinking about voltage, wire these multiple rows in series. So for example, let's say we have the same configuration of parallel rows, but this time we want to make, let's say, a 10.8 volt battery. So here we have 3 sets of parallel rows. Now don't forget, these are all joined down the cell like this. So they will have a piece of nickel connecting all the cells together. Okay, so all these have positive facing up, all these have negative facing up, all these have positive. You want them to be changing, so from positive to negative, etc. So that you can wire them in series, because that's how it works. It goes from positive to negative in series, and then in parallel it will go to positive to positive, negative to negative. So you will have these parallel rows all wired or connected with nickel like this. Now, to do it in series, you want to connect each cell to each other, just like this. So now you have multiple rows of cells all connected in parallel down like this, all these rows. However, all the rows are connected in series this way. So now, as we said before, that voltage adds up in series. We can do 3.6, add 3.6, add 3.6, or 3.6 times 3, but which gives us 10.8 volts. So for the application I'm using the battery pack for, I want about 20 amp hours or 20,000 milliamp hours. So the way that we can figure this out is that you can look at the capacity that you desire divided by capacity of each individual cell. So the cells I'm using are, if you're wondering, the not M26, M29 18650s. Okay, each one of them has a capacity of 2,500 milliamp hours, and as I want 20 amp hours or 20,000 milliamp hours, I can do 20,000 divided by 2,850. This gives me an answer of around 7. Can't remember the specific number, but it's very close to 20. So now I know that I need 7 cells in each parallel row, as they all add up. So it'll be 2,850 times by 7, which will obviously, because of the equation, get me to around 20,000 milliamp hours. So the next thing I need to do is figure out the voltage that I want. So it's pretty much the same principle. The voltage desired divided by the voltage of each cell. However, in 18650s the voltage is the same, they're all 3.6 volts. So for my motor I need 48 volts, each one is 3.6, so that gave me an answer of around 13. I think it gave me 13 times 3.6 is about 46.8, so that's close enough to 48 as I need. So the next thing is to look at a more advanced configuration of the cells. So to get a more advanced understanding of how I wanted to make this battery pack, I created a diagram. So as you can see on this, the positive facing rows are white, the negative facing rows are grey. So all the parallel groups are lined up like this, and you can see how they will be lined up in real life. And down each one of these is a nickel strip, so that will give them the parallel connection. They are on both sides, so this is the bottom and this is the top. I will link these diagrams in the description for you to have a look at as well. So what you can see is all these rows connected in parallel, and they're also connected in series. However, if you think about it as a circuit diagram, a battery normally is shown as 2 lines with wires coming out of it. So obviously you need for a whole battery you still need a positive and a negative end. So for this you have to leave out one on one side. So this is the top. For the top, this end positive row is not connected in series because that needs to be the pure positive connection for the things like the BMS, the charging leads, etc. So if we look on the back, we can see on this side the negative side is not connected in series to give the negative end of the battery. So if you think of this as a 3D object, but you're looking at a bird's eye angle, these are not this is not connected. However, on the underside these are all connected, nothing in the middle there. Go back to the top, these are connected. Go back to the bottom, these are connected. So it's almost like a snake going through the batteries and connecting them on both sides. So now the first thing to do is to start making these parallel groups. So as As I stated before, I need 7 in parallel, in each parallel group. So if you look on these batteries, there is a positive and a negative end. This is the positive, this is the negative. So what I was speaking about before is, I need a line of batteries all connected like this. So a piece of nickel across the top and across the bottom. Therefore they'll be connected in parallel. So what you want to do first off is just give this like row a bit of shape before you actually start welding, spot welding onto it. So all you need for this is a hot glue gun and something flat like a cardboard box, just to put the cells on whilst you glue them. So if you look here, the cells will all be connected like this. So all you want to do is put a bit of hot glue in between them. Don't need a lot, it's only a oh, I've just put a new stick in, that's why. Okay, just put a small amount of hot glue across there and then push them together like that. And then you can always stick them on the table, squish them together a bit, and then that is 2 of them connected. So all you need to do now is do that 7 times, 13 times doing that, and then you should have all your parallel groups. So I'll get back once I've done that. Okay, so all the cells have been glued together in rows like this. Doesn't need to be particularly neat, but as long as it does the job. So now I have 13 rows of 7 cells in parallel. So I put them together just to see about what size the battery will be, which is a pretty good size. It's about half the length of my forearm, so yeah, I'm happy with that. So in the next part of the video, we're going to be spot welding nickel down all the way down the positive terminals and down the negative terminals. Yes, so that's about it for this video. I will see you all in the next one.